Okay, today you get to learn about logarithms. Finally, we got here. And really, they aren't that hard. They sound more complicated than they really are. And the reason logarithms were created, if I had, let's do this problem, how do I solve it? Take the cube root of both sides. I have to undo that root by taking the cube root, or undo the exponent by taking the root, right? So if I have this problem, an exponential problem, because where x is the variable, it goes on, that function we've been learning about for the first 3 sections, an exponential function. How do I undo that? I can't take the xth root of both sides, right? So this is, someone just decided to figure out what the inverse of the exponent was. And they called it the logarithm. They just created the logarithm and said the logarithm is the inverse of the exponent. So if I've got, oh, don't do this to me. Drives me insane. I have an arrow at least. If I have x equals b to the x, this is called the base. The number on the bottom is always called the base, right? So in a logarithm, the base is the subscript. Okay? And I'm trying to solve for x, right? Y is, I shouldn't make it look so low, it's up here. Log base b of y equals x. That's how we get x down. That's how we undo the exponent, as we use a logarithm. Okay, so there's something that I think the textbook calls it a key. I want to use the same terminology they do, just not to confuse you. Log base b of a. To convert this to an exponent, that's how we go back and forth. One way to remember it, this is the way I always remember it. B is always the base, that subscript. And so with the exponent, it's always the base. And then I always remember these two numbers, when I put it with the exponent, here and here, can never be together. So the a is over here and the x is up here.
Interruption. Please report to the in-staff testing. Please take a look with you.
Another way to remember it is just draw a counterclockwise arrow. Start with b, raise it to the x, set that equal to a. Okay. Some examples of how this works. Maybe. And this is kind of an easy one. Oh my goodness. Eight equals 2 to the x. Anybody tell me what x is? What is it? 3. Yeah, 2 cubed is 8, right? So when I have a problem like this, it's pretty easy. I can figure out x without a logarithm. But if I want to put this as a log, x is equal to log base 2 of 8, which is 3. So what this does, 2 to the third power equals 8. That counterclockwise circle. You guys watching? I mean, they are kind of easy, but you have to understand them. Okay? So 2 to the third power equals 8. Where logs really come in handy is if it's not an even exponent. I mean, if I had 8 equals 3 to the x, that's not an integer. That's a decimal. How do I solve it without a logarithm? Okay? If everybody, I'm going to grab a calculator for everybody. I think one of you has one already, right? You've got one? Okay, I just needed one calculator. On the calculator, the log can be found, it's the fourth button up on the left. Everybody see LOG? If you just type in, well, let me review a couple more things first. This is base 2, right? If I write, oh my goodness. I'm about to go to the board. If I write this, and there is no base written, it is always 10. Log base 10 is called the common logarithm. And if there's no base written, you can just write in a 10, because that's what it is. If I want to figure out what log base 10 of 8 is in the calculator, I'm going to use that log button, because the log button in the calculator is always log base 10. No other base. That log button here is log base 10. So if I want to find log base 10 of 8, I'm just going to put log and put 8 in. Log base 10 of 8 is 0.903. And what this means is 10 to the x power, what number, if I take 10 and raise it to that number, will give me 8. That's how I undo the logarithm, to go back and forth. And if I raise 10 to the exponent I just discovered, raise it to that answer, I get 8. Okay? So if that 0.93, if everybody tried that, log base 10 of 8 in your calculator, and you got 0.9030899987, if I take 10 and I raise it to that number, that's equal to 8. It's how you go back and forth from exponents to logarithms. Okay? Now, if you run into a problem that doesn't have a base 10, and the calculator only gives you a base 10, you have to use something called the change of base formula. Okay? And the change of base formula, if I were going to do this one, log base 2 of 8, and I want to be able to use my calculator. Remember, the calculator, if I hit log, it's not log base 2, it's log base 10. So if I want to use the calculator to figure this out, I'm going to take log base 10 of 8, which I don't even need to write, right, over log base 10 of 2. If you put that in your calculator, you're going to get 3. Log base 10 of 8 divided by log base 10 of 2. 3. And we already said log base 2 of 8 was equal to 3. I just proved it with the calculator using the change of base formula. Okay, so to use the change of base formula, the numerator is always that, the denominator is the base, log base 10 of 2. A couple more things actually with logarithms. That was terrible. Log base, I don't know, let's just do 3 of 1. Log base 3 of 1. Who can tell me what that's equal to? Think about how I would convert it to an exponent. Let's say I make this equal to x. How would I write this in exponential form? What's the base? Right, we go this counterclockwise. That's how I'd write it in exponential form. What is x? No. What number is any number raised to that's always equal to 1? Doesn't matter whether it's 1 through a million, you raise it to a certain number and it's always equal to 1. 0. So anytime I have log of any base, let's just call it b, of 1, doesn't matter what the base is, that's always 0. Because any base raised to the power of 0 is always 1. Okay? How about this one? What's that equal to? We'll put it in exponent form. 1. So anytime you have log of some base raised to, or of that base, if those two numbers are the same, it's always equal to 1. Okay, so these two properties here are important to know. And if you can't remember them, just change it to the exponential form and ask yourself what x is, because you should be able to figure it out then. Okay. There's one more logarithm. I can get my board to work again. And that is log base e. Let's just call it log base e. Remember what e is. What's it called? The natural number, Euler's number, e. We use it with continuous compounding. It's equal to about 2.713 something or other, between 2 and 3. It's an actual number. But anytime I do log base e, they don't call it log base e. They call it natural log, ln. ln means log base e, just like log means log base 10. If you see ln, it's called natural log, and it's called natural log because e is called the natural number. So ln is the inverse of e. Okay? So if I have y equals e to the x, and I want to undo this, the base is e, so I could write log base e, but that's not log base e, it's actually ln. ln y equals x. The thing that helped me the most when I first learned about ln is on paper and in my head, I always just wrote log base e until it clicked. Because it's the same thing as natural log, but it made sense in my head because I'm trying to learn the base and all of these things, and if there's no base to it, then it confused me. So I just rewrote ln every time I saw it to log base e, which is fine. But just know in the calculator, ln means log base e. So anytime you're asked to find the natural log of something, you use that ln button. Okay? If you want to write log base e just to clear it in your head and make sense of it, do that until it finally clicks and you understand what it means. Okay? So we have a couple of important topics here. We have the common log, which is log base 10. So anytime you never see a log base, you always know it's 10. Just like anytime you see the number 3, you always know it's raised to the first power, or it's multiplied by 1. You don't have to write it, it's just given. So anytime you see log of any number with no base, it's always 10. That's called the common log. Anytime you see natural log, this is what it means, log base e. So when we start learning how to solve exponential equations, which we're going to get to, not today, but we're going to get to, when you undo an e to the x, you always use natural log. You don't use the log, common log. Okay? A couple of examples. that they did, I think, in the textbook. How could I evaluate log of 1,000? How do I write this as an exponent? What's the base? 10. If you ever have this and they don't give you a variable, but they want you to solve it, create your own variable. Okay? Because now I can write this. I know how to go from logarithms to exponents. The base is 10. I go from the base back around, so it's 10 to the x is 1,000. Now, what is that? 10 to what power is 1,000? 10 squared is 100. 100 times 10, 1,000. It just tells you really how many decimal places it moves over. Right? 10 to the 1 is just 10. 10 squared is 100. 10 cubed is 1,000. So I know log of 1,000 equals 3. Let's do another one. Log base 2 of 32. What is it asking in words? Two to what power equals 32? What is it? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Right? 2, 4, 8, 16, 32, 5. 2 to the 5th power is 32. How about one like this? -1. It's asking 10 to what power is 1/10? Well, -1 flips it. 10 to the -1 is 1/10. Okay. What's another one? Let's do this one. What's it asking? 1/3 to what power equals 27? Well, 1/3 to what power equals 3? -1. And 3 to what power is 27? 3. So the answer is -3. Kind of starting to get the feel for this? Once you start learning these rules, it's not bad, but it just looks foreign the first time you hear about it. I'll try one more. How would I do let's go 4 times 5 to the x equals 10. How would I go about solving this for x? There should be one step that the very first step should be pretty easy. I would want to isolate the 5 to the x term. Divide by 4. So 5 to the x equals what? 5/2? Now, how do I convert this to a logarithm? Log base, what? What's the base? 5 of 5/2 equals x. Now, I can't think of an exponent of 5 that gives me 5 halves. So how could I solve this with the calculator? Log 5. Change of base formula. Change of base formula says I can make it the common log. Put a 10 there. I don't have to write it, though. And just put it in the calculator. Log of 5 halves divided by log of 5. And it's 0.569 about. Okay, so if they're not obvious integers, like 2 to the 5th is 32, 2 cubed is 8, 3 cubed is 27, if they don't just come to you, use the change of base formula. And you can solve them. Okay, so logarithms are a way of undoing the exponent. Okay, so let's look at our textbook check. A logarithm is the inverse of an exponential function. Log base 3 of 27. 3 to what power is 27? 3. Log base b of 1. 0. Always, because b to the 0 power is 1. Log base b of b, 1, because b to the first power is b. And log base, well, there's no base. Log of 35 is the same as log base 10 of 35. True. That's called the common log. Okay? Questions on that or anything else? Okay.